Number 14. A bell-shaped set of data has a mean of 42 and a standard deviation of 7. What percent of the data could you expect between 28 and 56? Well, one of the easiest ways of solving this is to draw out a number line and put the mean right in the center of that number line. So I'll put 42 right here. And then start marking off the number line in terms of distances measured in standard deviations. So the standard deviation is 7. So if I take 42 plus 7, one standard deviation to the right is 49. And then if I go one additional standard deviation, 49 plus 7 more gives me 56. And I notice that 56 is one of the values that I'm interested in finding. Going the other direction, one standard deviation to the left, to get that means I need to subtract 42 minus 7, which gives me 35. And then if I subtract one more standard deviation, I would take 35 minus 7, which gives me 28. And so there's the other value that I was interested in. What this means is the two values that I'm interested in, they are two standard deviations away from the mean. And the empirical rule guarantees us, and I know that I can use the empirical rule because the data set is bell-shaped. The percent of the data between 28 and 56 is going to be 95%. And that's how we would solve this. But another way we could have gone about determining how far away 56 and 28 were from the mean measured in standard deviations was to use a z-score. So I could have taken 56 minus my mean, which is 42. And if I subtract those two values, that gives me a total distance of 14 units. But if I divide that distance by the standard deviation, it tells me how many standard deviations away it is, and I get 2. And if I use 28 using the z-score formula, I would get -2. Either way, as long as you arrive at 95% for your final answer, everything's fine.